Back in February, I suppose it was, when we had the cold, really cold weather during FOSDEM and Configuration Management Camp, Bernd approached me and was asking, hey Martin, wouldn't you mind sending in a paper for the OSDC? And so I said, okay, I can think about something. And when I was back in Berlin, I was at a customer. And within one customer, we really had a very, very interesting meeting and interesting discussions. And based on these discussions and the meeting we had about there and what I heard from the people, I decided, okay, I will provide a talk for OSDC. I was quite astonished when I heard, when I learned from the organizers that Bernd decided to go for a talk with a quite aggressive term like ops hates containers. Please don't forget the next word, why. So what I want to do is, by the way, who's here and saying I'm more an ops than a dev? That's basically the majority. Okay, otherwise you wouldn't be here, yeah, because developer loves containers, ops hates containers, so you must be here and must be ops people, for sure. So what we usually do at customers, we provide support and consulting for IT automation. We have a specialized expertise when it comes to Puppet areas, but well, automation doesn't only deal with Puppet, it also deals with an infrastructure by itself. And this is what I mentioned. We had a funny meeting. One of the ops people approached me when I being at a customer, and he was asking me, hey Martin, we have an invitation from the developers. I told him, whoa, that's great, you start talking, that's nice. So please go to the meeting and don't abandon the meeting. You won't know what happens over there. Yeah, they want to talk about containers. They want to bring Docker into production. I said, yeah, that's awesome, that's cool. You can concentrate on the real things to do. Scaling, infrastructure, storage, network, and you'd never ever deal again with any kind of application. He looked quite astonished and said, are you really sure? Because that's something that you understand, but the developers might have another understanding on what's going on. Okay, I will join the meeting. By the way, is security also invited to that meeting? And he had a look on the invitation, says no. Invite one from security. So we cover all the aspects that we need when it comes to containers in a production platform. So the meeting started, and first the developers were quite shocked and saying, why is this IT infrastructure engineer here and why do we have security here? We're talking about things which are completely unrelated to them. And they started with topics like Ops must build the core containers, the base containers. Ops is responsible for running the containers. Development is responsible for building the containers. Ops is responsible for the security of the containers. Ops is responsible for staging containers. So they have this three-stage, let's say, delivery platform. So they start in development, they have some testing environment, and they have the production environment. So Ops is responsible also for staging the containers. And they were just pushing out work to be done to the operations people. Then the operations people started talking like, how do we build containers? We've never done that before, base containers. What is it that we must have inside? What is it that we should not have inside? Should it just be a copy of the operating system? What's it? And somehow came the security person into approach, saying, stop this discussion. This is completely going wrong direction. So first of all, ops can't ensure security in containers because containers are built by the developers, and from ops perspective, containers are like binaries. You can't look into something that is compiled stuff. It's binary code. You can only do that on source code level. And the same is what he sees for the containers. And the next thing was stating, and by the way, developers must name the C groups that must be set and the kernel capabilities for each container process. And then the funny thing happened. The developer that has announced himself as being the lead architect for containerization, he was asking, what's that? That was the point where security stopped the whole meeting, saying, go home, do your homework, learn about the basics of technology you want to use, and never ever dare again to use the term Docker. So, Docker. it's always fun when being at that customer. You walk around through the areas and you always hear some mumbling anywhere, and it's always the same. It's like Docker, 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 Docker. They all talk about containers, and they just think about Docker. But the real approach should be, look at what are containers really? What makes a container? What is a container? So why do we have containers at all? Oh, we don't need configuration management anymore. Because a container is isolated, it's just environment variables that make everything working magically. It's so easy. We put everything into Redis, and then we're fine, we're good to go. It's so easy to build and deploy. It's just a Docker pull, Docker run, everything's working. Have you seen it on my laptop? It's here. I have everything on my laptop, yeah. Okay, how many laptops do we now place in the data center? Yeah. It's so easy to test and verify. It's so easy, even if you break things, you just build a new release and things are also good again. And even if the new release is just a revert of the last commit which broke things. Absolutely fine. So it's super easy doing containers. And yeah, you don't need, containers are some kind of self-healing magic platforms where you just say, I want something, and the platform knows what you want, and it does it automatically for you. It's really myths that you see around there. So you don't need to check for security because containers are short-living instances only. So nobody can log in and do something. And by the way, there is no shell inside. So how could someone log in? So we don't need security. Log in. So we don't have to dig inside the container. What about the logs? Logs are just, well, do you really want to see 3,500 Java exceptions per second, if that is what you call a log? Okay. Don't laugh, don't laugh. They have the big Splunk license exactly for that reason. When asking them, isn't it possible to reduce the log level, maybe to something like info? That would be nice. We tried it, and the application is not working. Wow, okay. And this is something you want to Dockerize. Interesting. Okay, so what else is it that we have as rumors around? You don't. We can do ops and serverless. Well, yeah, opsless and serverless. We don't need servers, so we just put everything somewhere, a jumpy cloud, and we just throw containers at the cloud. Full step. So it's a myth about containers we see. So why do people start with Docker? Because it's the most easy concept. Yeah, they just install something. Okay, it's a package from the vendor, it's signed. Okay. The next thing they do is Docker pull any kind of things out there in the internet, and this always reminds me like the curl -k HTTPS. When you do HTTPS, why do you do -k? So ignoring any kind of security which is in SSL. So, and you pipe everything either in bash, or if you are unsure whether this is run as root, you pipe it into sudo bash. So make it working. A couple of years ago, there was at the config management camp a keynote where one was asking, okay, who's using upstream mirrors? And 60% were raising their hands. So, by the way, who's not mirroring upstream repository servers, but using directly upstream servers? Nobody dares to raise his hand. Okay. Because I forgot who it was, but the wording still stuck in my mind, and he mentioned to the people, oh, you're having unprotected sex with the internet. Nice. Yeah, but it's easy. It's super easy to say, okay, I want to have a database server, I want to have a web server, and I want to have my application running on the web server. I'm not interested in some kind of scaling. I just want to develop code, do it as fast as possible, maybe by mounting a volume inside the web server, so I have my application locally and I can directly test it and I have a database connected to it. That's great, that's awesome. So, but what else is a container seeing from an ops perspective? From an ops perspective, we say a container is it's a change route. So something which has been there at BSD for years, the jail process. Nothing else is a container. It's a change route process. And it doesn't need to be a full-blown operating system. It might be just some specific binaries and the libraries that binary needs. Maybe just libc and some application. That's it, full stop. No need to have more inside. With Docker, you say you have this this kind of overlay file systems underneath. So every change you do is something like see it like a git commit you do on a code base. And this is something you do on the container. You have the core container, and then you add layers on top, which is, of course, also affecting, well, performance when it comes to file system operations, because it's this multiple layers of file system that cause I/O to be very, very low. The next thing we see is you can't run containers in somewhere, nowhere. You need some infrastructure underneath. So you need to have some hardware. There must be something where you can deploy a container. And even if it's just a standard operating system and you have the Docker daemon running inside, or some kind of others, then you are able to deploy and run containers. And see containers like being a binary. So you get it shipped from a developer. The developer says you about the state. He has checked the state and saying this is development state, this is production ready state. And then you just pull this binary and you try to run this binary. Well, this is what you do on one node level only. So this is some kind of basic concepts when it comes to containers in general. What is it that the next thing we did after the meeting without the developers, but together with the ops people, the network engineers, the database engineers, and the security? We said, okay, we see there is a specific need, especially for the new modern platform that has been built. There was already the policy made, it should run on OpenShift, whoever made that decision, but it's already there, saying we want to go OpenShift as the infrastructure to run containers inside. So we were aware we have to deal with this issue somehow. And we must find a way to understand what's happening inside, how to deal with containers, how to work with containers in the most easy pattern which is possible. So the KISS principle. Sometimes I see this is not happening when you see all the tools that blow up around containers. They all try to solve, sometimes they try to solve the same, sometimes they address new issues. And there's one thing which people must be totally aware about. And I try to get into this by drawing some graphs, overlay some graphs. So this is the past, the present, the future, let's say it this way. In the past, people had a mainframe. There was only one mainframe, down in the cellar, or maybe at another building. When the mainframe was, somehow new systems showed up, it was personal computers, so nobody had a terminal, but everybody has its own computer next to his desk and was working on his own computer. You had more systems with that. Then people said, okay, but we want to make better usage and separation of servers. So we don't want to throw all services directly onto one server, but we want to distribute them on one server by running them in virtual machines. So we can better make usage of the computing power we have. So let's combine services that run through the day and run through the night as virtual machines. So still isolated from an application perspective, and put together due to the virtualization. And then we receive containers now. And be aware that this is not, the scale here is logarithmic. It's not linear. Forget about it. So I see that the customer, they first had 20 servers over there. They still have 20 servers, yes, but now they are used for virtualization. So it's no longer 20 servers serving the development platform. They have 1,000 VMs running on that 20 servers. And if we go to containers, I suppose we have now 5 Dockers running over there. So basically it's static things, nothing that changes very, very fast, mostly for CI pipelines and dashboarding. And we already see 250 containers showing up. So quite interesting how you see the numbers of systems exploding. With the numbers of systems exploding, there is one graph that directly points downwards, which is the uptime graph. So on a mainframe was just there and running. Then you had this PC components, the server components. Yeah, they had some downtimes. Sometimes they were hardware issues, kernel upgrades, and stuff like that. And I still remember this marketing video from that Hamburg company. They were saying, hey, we're a cool company, we need new employees, and we do fun stuff. For example, moving from one office to the new office and having our core router, a BSD system, they put it into public transportation. They had an UPS connected to it, so it had power, and they had a small GSM modem to it, so the monitoring could still ping it and shows it's non-disruptive, it's still working because it has an uptime of 560 days and we want to make it 600 days. Anybody here with a security background? I'm just interested in your opinion of 560 days uptime. Sounds weird, but that was the time where people were really proud. You've seen it in the talk from telecom people. They were talking about the old times. And they said, yeah, we were proud of having huge uptimes. That was something they can prove. We are able to run a stable platform. Usually I try to make jokes, but no manager around here. Then I can do that joke. At one customer, we said, we need a stable platform. And I told him, yes, you know, dead is also a stable state. Management was not really happy about that. So when you have virtual machines, downtime is even lower. Even if maybe you freeze them for 2 or 3 seconds while moving them to another cluster, but be sure this is a downtime. It's 2 or 3 seconds downtime, so it's not uptime anymore. And with containers are built to purpose a small specific use case, and containers are destroyed when no longer needed, or are for update processes, there is no update process. Roll out the new version of the container and terminate the old version. And then you're good to go. So there are even far more shorter living instances. So more systems with less uptime usually means more work. So more systems already means more work. But now they have lower uptime, so I have more to do. Yeah, let's look on how the standard employee number development takes place. Usually you see, okay, numbers of systems are increasing exponentially, but numbers of staff is not increasing exponentially, at least not in ops or development or DevOps or IT organizations. Which only leads to one thing. So we have a plenitude of servers more, with lower downtime, more work to do, with the same amount of people, means you must go to 100% automation. Otherwise, you're lost. Everything must be automated. The whole setup of your whole infrastructure, everything you need. Regardless whether it's a storage system, centralized databases, everything that is involved into containers must be automated. From the past, who is aware of the 80-20 principle? Usually it refers to you can do 80% of the things in 20% of the time. So usually people say, do these 80% and spend the rest of your 80% time, do something different. But this has changed now. We still have the 80-20% principle, but it means when you don't do 100% and you do 80% only in an automated pattern and 20% of your time, you afterwards use 80% of the time on doing the stuff manually that you didn't automate. Automate everything. When people ask me, should we really automate everything? Yes, automate everything. Otherwise it takes your whole business time for doing things you've not automated. Okay, we know we have to automate stuff. We already got some ideas about containers, but let's look a little bit more into now multiple containers. We had the single containers where I told you this is something like a binary, and you just run the binary somewhere. And the binary has a version, and developers provide you with new versions of these binaries. Maybe you even ask them, please provide us some configuration switches to enable debugging, to redirect logging to someplace else, so that you can deal with this application from an ops perspective. So containers itself usually are there for being short-living instances. They don't run for 340 days. At least I've never seen a container running that long. Usually they're not meant for. There's a website describing what you should think about when building, deploying, and running containers, especially the build process is meant by this 12-factor. Check out the 12-factor when dealing with containers. It's a strategy how you should start thinking when working on or with containers. Which means don't manage containers as permanent systems, destroy them when they are not working or when you have a new release at hand. Think about your data. Containers are really nice when you say, I have non-persistent data. A container gets a request, he processes a request and sends the request to someplace else or answers back to who has ever sent the request. This is really nice for containers because mostly this is taking place in memory and not on disk. Everything which is happening on disk is first, when you have it locally in the container, it's slow. Then people say, oh yeah, but you can just bind volumes to it, so you can pass through the underlying file system into the container, so it's no problem at all of having the database server running inside the container, so at least the database engine is running in a container, the database itself is outside of the container. Yeah, that's true for when you see one single node only, where you run multiple containers. But think about multiple systems where you want to deploy containers upon. So on one is the file system for the database. What's on the other? We should place this on, how is this called? No such file system? Nightmare file system? NFS. Place it somewhere on a shared storage. Okay, make it redundant, make it GPFS or an Oracle cluster file system or something like that. Okay. When you deal with containers, try working on them and try to break them as early as possible. And that's so horrible easy. We played around with containers. The first thing we learned, okay, we are not allowed to pull images from the internet. Oh, we have to run our own registry server. Okay, there is a registry server which you could Docker pull, so you have the registry server which needs internet access. So that was the only exception we received from security, saying, okay, you are allowed to pull the registry container, so you have a registry container locally, and that's the last thing you pull from Docker Hub. Afterwards, we changed DNS to point Docker Hub to either localhost or to our internal registry server, something like this. So nobody may pull from the internet. curl-k pipe sudo bash, yeah. Check what happens when you have instances running. What happens if someone says, I have to do a maintenance, I want to change something on the Docker configuration, and I restart the Docker daemon, and suddenly you wonder, where the hell are all of my containers? They have nicely vanished and disappeared when the Docker daemon went down. No, and these are not like services that will be up again in an automatic pattern. You have to start them again. The most severe one, we started using Docker in CI/CD. So we want to do testing on our automation of the CI/CD setup. Well, this time we do Puppet, not Ansible, so because I don't like Ansible, so answering the thing to the telecom people, but that's okay. And we also want to test that our configuration management tool configures our CI systems accordingly. What is it that we have running inside a CI system? We have a Dockerd running inside. So we have the CI server itself in production state having a Docker daemon running. In that Docker daemon, we want to deploy a CI server that has a Docker daemon running inside. There are plenty of solutions that tells you, point to the outbound Docker to the pipe so you can connect it to the outbound Docker. But that's not the real test. So we want to test that we are really able to deploy a Docker daemon even if it's inside a Docker container. It took us around about 4 weeks discovering lots of interesting things which are recommended to do, recommended to not do, and the only way we were able to do it afterwards, saying we use different underlying overlay file systems, one on the real CI server and one which we use inside the Dockerd of a CI server. But it's an interesting thing. You see, it's not scaling like virtualization, where you can say, I can have KVM inside KVM inside KVM, whether that's useful or not, but it's easy to do, but not with Docker. You have this one layer usually only. And the setup we've chosen here within the CI/CD platform with these two different overlay file system, the file system that we have inside an CI instance running inside a Dockerd is definitely running in not recommended for production mode. So this is where we started learning about how do we build containers? How do we deal with the registry? How can we secure the registry? How can we limit access to the registry? So production should never fetch a development state of a container. It should always fetch the production state. We started working on the most simple thing we could think about, and this is our CI/CD solution. So saying we have built processes. And first we as let's say we are the IT infrastructure engineers over there. And we told nobody. So we talked to security, hey, we would like to have a Dockerd running in our CI/CD platform. We would just want to use it for build processes and CI/CD, nothing else. And they said, yeah, okay, think about the registry server and never ever pull anything from outside, build your own things. Okay, so we learned about how to create tarballs to make containers from tarballs, so we have our minimal container available for us. The next thing we saw was where we really found it very useful were building dashboards. So every developer team has somehow a dashboard showing their interesting metrics which are relevant to the team accordingly. So we also started, okay, let's build our dashboard that we need also as a Docker daemon, so as a Docker container. After a couple of 2 weeks, we had a look at the systems, and we were wondering, what the hell is happening here? There's lots of containers running. Yeah, one of the developers somehow had a look at the CI/CD server, and he was learning, wow, there's Dockerd running. So they started, first they started to pull from Docker Hub. They learned it's not possible. So they learned, but wait, we have something like an internal registry. Okay, let's use that internal registry. See, we get a base CentOS system. Okay, a little bit stripped down, yes. But already in the way how the customer wanted to have a CentOS system set up. And then they started playing around with it. Some forgot to delete the containers after they were useful, so they were just there and running. And this was all the process where we learned about what is it that you can do wrong when you just do containers. One team was showing up and saying, we have troubles, we have now everything containerized, and our build process is now taking 50 minutes longer than usually. What the hell is wrong? And we had a look and we said, yes, it's 50 minutes, you're waiting for Docker pull. Why the hell are you building a 2.5 gigabyte sized container every 2 hours? It makes no sense. So every time you build a new container, you trigger the deployment and test process, which means pulling the new container and then starting the build and test process. So maybe that's not the right choice for a container, putting 2.5 gigabytes of Google Android binaries inside. So what else? What is the next step that we are heading to? We say, okay, at the moment we have Docker daemon running on a single host. We have Docker instances running inside this Dockerd. Mostly they are encapsulated, so when they need something, they have access to the internal network via the host underneath. So basically they can do something like nutting on the host underneath. There's no need for them to be available from remote, except for the ones we use for acceptance testing, our configuration management. These are spun up in a way that there's port forwarding and SSH enabled inside. So we can SSH in and run server spec inside. But when it comes to now the real problem of ops people, we have a larger infrastructure. We have more to do. So we must ensure something like container management. So we must be able to have a centralized system that allows us to manage multiple containers spread amongst multiple Dockerd instances or whatever is the container engine that you are using. So you want to have something like an orchestration. So orchestration can start with, I want to run an update. So the update is easy, as we already know. Destroy the old containers, spin up new containers. How about the database migration schema? Schema migration. Okay, maybe this is a permanent system, not a Docker daemon, but you somehow also must orchestrate that next to it. What is it that when you want to do some hardware maintenance on a system underneath, you have to take the system out of service, and anything that is running on that must be moved to some other place, also some kind of management, maintenance. You have to deal about the networking stack. So maybe you want to have applications being available from external. So you want to have a service somehow offering, a web service, a database service, a Redis service, whatsoever. So you must think about, how do I get traffic inside my containers and how do I get the traffic out of the containers? And there's plenty solutions around. So the next thing we do is playing around with container engines. And there, of course, we want to test everything up front. Things that we see in a data center, hardware dying. So just kill off a system which has containers running and wait for the container management that the containers that have been down are spinned up again in the state as we want to have them. Usually you see with the first documentation we saw when it comes to, in this case specific to K8s, as we call it, Kubernetes, is that they say, the most easy thing is to just have the Kubernetes AP servers running as a Docker container. Wait, the core of your container management is running in a container. This somehow sounds weird, like a hen-egg problem. How do I get the container there, the container engine there first? So things that we already see, it's hard to find good documentation on how to build a production-ready cluster for Kubernetes. I know people doing it, and as far as I have heard, many of them say, no, we don't run the API server in a container. Some say, yeah, we run it in a container. When it's not there, everything is functional. You just can't do things new or change something. Depends on what you want. You have to check whether this is a good idea. We want to deal with people misconfiguring any kind of container engine. So doing things wrong, not by accident. No, doing by accident is something that can do everybody. Everybody does it once or twice while doing IT works, that's usual. But we want to, by purpose, configure something wrong and see how things are behaving. We want to see how can we upgrade. Some people recommend build the new container management platform in the new version next to it and migrate everything over. Or do we really inline upgrade the existing container management solution? Then people start discussing, should we run containers by ourselves? Should we use some external party that delivers this as a service, whether it's Google Compute, Amazon? Well, mostly that depends on your policy regarding data protection. Can you run in a public cloud or not? Must you run on-premise or not? And these systems that are usually public offered things, I only see them running Kubernetes. I've never seen someone saying something different, that they do some different container engine underneath. But please think, what is it that you want to achieve? So Kubernetes is very complex. That's the reason why there's many distributions like AWS Kubernetes, Google Kubernetes, OpenShift, which is a distribution that bundles Kubernetes. There's OpenShift Origin, I suppose, which you can run locally on your own data center. There's some hosted solution available. So these are all distributions that try to offer you the most easy way to get a Kubernetes cluster up and running so you can deploy containers inside. Yeah, it's super scalable. It's what people tend to say the Google-esque way of doing things. So planning for building data centers on Mars. Do you want to have data centers on Mars? Would be interesting, measuring latency over there, yeah. But I don't see the need, actually. I don't want to live on Mars either. So maybe you will need something in a far more smaller scale. And we heard it already this morning from Mitchell. He was talking about Terraform. Yeah, he already mentioned Terraform is not for bare metal. For bare metal, you can use something like Nomad, and Nomad will do the bare metal thing, and then you can continue working with Terraform. You can check Mesos, they have something in place. Netflix had recently released their container management engine under open source license. Maybe it's even bundled with every Docker installation that Docker Swarm is already sufficient for you to deal with. So you can use Docker Machine to deploy Docker-D on a machine, and afterwards Docker Swarm to deploy containers on all of your Docker machines. Or you go to CoreOS and Rocket. So there's plenty solutions around. And check what is the best way for you, what is the thing that you can deal best with. When you say, okay, we are forced to go to any kind of supported version anyway, so we have a Red Hat contract, we have the satellite server, so we now just order on top the OpenShift platform, then for sure you will receive Kubernetes. But okay, then I can skip everything, I don't have to deal with Docker, I just install OpenShift and I start with OpenShift. This is what they did at my customer. And after 3 months, the IT ops people said, okay, so we had this couple of hours per day time digging into this, but we don't understand it, we don't get it. We don't know how to run this thing, we don't know how to manage this thing. There's documentation, but it's all new terms and wording, and everything looks different. There's software-defined networking, there's nothing we can really touch, there's no cables, there's no switches, no routers, there's no real hardware underneath. And that's the reason why we decided, okay, we do the slow path. We first introduce Dockerd, we want to learn about the issues with containers. Then we can move on to any kind of whatever is the solution that you want to have. That customer made the decision OpenShift, so we're going for Kubernetes. We want to learn and understand how Kubernetes is working. When we have an understanding on that and we can run it on-premise, then we can move forward for knowing, okay, now we have the knowledge required for running a container management solution based on Kubernetes because we have an understanding for it. We are absolutely sure some things will work different in a distribution compared to a standalone non-modified Kubernetes cluster, for sure. But getting the basics and the understanding how things are working, this is the most important things. What was in the past? The mainframe. Yes. No, there was something different. When we do containers, there's no need for configuration management because data is just is no longer needed. The container knows everything where it should connect to. Okay. But what about your database? Maybe you have a specific need for a database. Do you really want, is it supported by Oracle to run a REC cluster in containers? I don't know. Ask Oracle people. They will tell you whether you get support for that. How about your Exadata? I've never seen someone moving Exadata into containers. Maybe Oracle does this internally, but not for public customers. So you still might have a need for specific things, infrastructure components, where you say these infrastructure components are still somehow managed in the old pattern. You will never ever migrate them over to some kind of container. A big bloated Java engine that needs 3.5 minutes to just initialize and then wait 4 more minutes till it's able to serve a request. That's definitely not something you want to put into the container. At least when now this Java application needs again 2 minutes to shut down afterwards. That's not the right use case for containers. This is something you want to keep on VM or on Metal. The other thing is monitoring. So usually you see what kind of monitoring, who uses Isinga Nagios? Quite a couple of them. How do you manage to add new systems and remove them? I hear it. Yeah, you have to modify the configuration file. We do that automatic via Ansible playbooks. We do that automatic via PuppetDB. So yeah, there are solutions for doing that automatic. But how flexible is this? And now you want to have something like a platform which looks like there's constant defibrillation taking place. Nothing is living permanently. Everything is moving around. And this is something you want to monitor with a static monitoring solution. No, it's not the right use case for having something in place like the standard monitoring solution. Rethink how to gather informations from the system. Maybe stop thinking about the single binaries, the single containers. Look more that the whole platform is running. You are interested that there are at least 4 of these web server instances. Then monitor that there are at least 4. And when there's 27, everything is fine. Your constraint was at least 4. Maybe you can say no, not more than 80. Okay, because then there's something wrong with tearing them down again. But this is a different way of monitoring. It goes more into the terms of metrics. You definitely want to know about your container engine state. You want to know about your container internal state. So dig for these informations. What we usually see, and we have great experience made with it, is Prometheus with a Grafana dashboard. I suppose you heard that today already 3 or 4 times. It always in combination with containers usually comes somehow Prometheus for metric collection with the alert manager and stuff like that. And the funny thing, we were digging into Sensu, we were digging into Isinga, we were digging into Prometheus. We showed everything to our product owner, and our product owner had a look on the interfaces, and he said, that's the one I like most. It was the Grafana dashboard for Prometheus, and now he's sitting there building dashboards for us. That's a great job for a product owner. That's really cool. Look inside containers. So, for example, we had some issues with it with the Google C-Advisor, mostly due to this Docker and Docker thingy. But C-Advisor analyzes your running Docker daemon on what other instances are running here. What's the health state of the whole system, plus what's the health state of each of the containers running on the system. Go for Zystic, go for, Lumogon, something that Puppet developed, saying it gives you an insight what's happening inside of your containers. Yeah, in the past we had hardware, and now? So do you really put everything into AWS, your whole development platform? Everything onto Google Compute? Maybe you still have your own servers, so you want to host something locally. So I always find this funny that when there was on the DevOps Days Berlin, there was a talk from someone mentioning, and then we did all the great things you should do nowadays. So the first thing is we went opsless. So no ops needed for anything, because we are already serverless. And then they learned that, but we need an understanding about networking, we need about firewalling, we need about security, kernel, and that's not something which is a developer's scope of work. So that's the point where they recognize, opsless is only possible when you have ops, otherwise you can't do opsless. But when you have ops, you're not opsless. The same they learned about their servers, saying, we are going serverless. That means we no longer have somehow Activa in our rack, placed in the rack. So just put money in a rack. Because we have everything put out into cloud. Maybe some systems you still want to have internally. Maybe your network connection to the outside is broken. You fully rely on foreign people infrastructure. And then they also learned, it's not really possible doing serverless without a server, at least a monitoring server that monitors the connection to the serverless infrastructure, which is your first server. What other companies learned when they grow huge in scale on public cloud usage, there comes the point where finance will ask you, what the hell are you doing? You're burning our money. Why? We have 80,000 permanent extra large instances running in Amazon. And that's the normal, and it doubles during peak times. And then finance will come to you and tell you differences between capital expenses and operational expenses, and they will give you some insights why capital expenses make more sense than operational expenses, which means capital expenses is your servers in your data center, operational expenses is your cloud thingy. So, and they will tell you maybe it's better to use own hardware because in the end effect it's cheaper for the company to run on own hardware than on some kind of cloud provider. So there's still things you might discuss. Not everything might move into cloud. Not everything might go into the container. We have plenty of time left afterwards. Definitely what you want to do is, don't be afraid of containers. Don't shout at developers that just walk around claiming Docker, 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 Docker. Let them just continue. They say, yes, you want to do something to have an easy environment where you can develop your code for your application. But please stop thinking about putting this as is into the data center. We need infrastructure inside the data center which allows you to run what you will ship to us. Containers will come sooner or later. What was it now with one customer, a financial institution from the government? They have the first request from another company which develops code for the finance institutions. And they already have asked, wouldn't it be easier for you if we would just ship you Docker containers? And the ops people said, we have heard about that. So we suppose 5 to 8 years from now we are able to run Docker containers. So they will come sooner or later. And some institutions are faster developing, are faster moving than governmental organizations. But even governmental organizations learn and understand that there is something new, which is a benefit for developer. Maybe they should shift from an operational perspective to something that supports developers. They are coming. Don't choose tool chains where you are completely unfamiliar with and you don't know how to fix them. Either you buy a supported one, and in case that something is not working, you just raise your telephone and you scream to the person at the other end of the line. Make it fixed by yesterday. Okay. Or gain internally knowledge about the things that are happening there. Don't build a silo. Spread the knowledge. Let everybody participate. If it's a huge platform like a Kubernetes where you have the ingress and egress and the proxy and the DNS and other stuff, let not just one collect all the knowledge, but try to give pieces to each of everybody, so that together they are able to manage such a platform. 80-20 pattern? Stop doing it. It's just a waste of time. At least when it comes to containers and you want to manage containers. Maybe you won't automate the initial creation of your Oracle database. Yeah, okay, this is something you restore from a backup. Okay, there are certain things where you say, okay, maybe not just tearing down the whole data center in an automatic pattern. You want to have some security implications, not just tear down all virtual machines running. But try for building, the purpose for building. So was it Mitchell who had the CRUD thingy? Who's familiar with CRUD? Only a couple? Okay. It's the analogy, the life cycle. It's create, it's run, it's update and destroy. And what CRU, this is the stuff that you want to completely automate. Where you say, this is the thing where I say, this is hands-off platform. And when a customer asks me why hands-off platform, I tell them, that's absolutely easy. If I see someone logging in via his console, I will chop off his hands. So this is a hands-off platform. So hands-off platform where you don't have to deal with initialization of the platform. Automate everything in terms of initialization. I know it sounds a little bit wobbly. Choose wisely. Check for the tools that are there. Look for what is it that I need to know. We've learned for Terraform, maybe some knowledge in Go, basic knowledge in Go is something you should gain when going for Terraform. When it comes to containers, learn that most things in containers in the container world are written in Go, due to performance, due to small memory footprint, small CPU footprint. So you might want to go for Go anyway. At least have some learning for Go. Otherwise, I can just say, Ops hates containers. I don't know why. It's just a matter of how you see the container world. Thank you.
So, for some questions. Okay.
How did you solve the responsibility issue? I mean, initially you showed that dev demanded what ops should care of.
Yeah.
Ops had a different perspective. They said, you give us a container, we start running the container, but what's inside is your job. Security, patch management, I don't know if for data services, backup and restore or something like that.
Okay, the question was regarding responsibilities. In the beginning, I talked about dev demanded to ops, this is the stuff that you have to do. Security demanded to development, this is what you have to do. The agreement is a responsibility is shared, full stop. So that's the first thing. So everybody is taking sure on a certain aspect on the container world. So what they agreed upon is that ops will do the base container. So this is something where they say, yeah, they want to provide a system upgrade, so they prepare new containers. Absolutely fine. Maybe even preparing them for underneath kernel upgrades, if required. The next thing is, and they take care on the, let's say, on this lower level security, from security perspective. And then there's the development part, and the developers are responsible for the applications inside these containers. And they are responsible for the whole security stack inside their application, so that they do not break things which have been done on the baseline. So they are not allowed to change existing security values. For example, some sysctl settings, some rules you have inside the container running. But they are responsible for, let's say, for the remaining up to the application level, up to the security level. The developers are staging their applications because they are rolling out their applications. So they must be able to stage their application, saying this is a development state, this is a testing state, this is a production state. Because Ops is now more taking care on the infrastructure underneath, so that they have everything running, that they have the required storage systems, network connectivity, they take care on scaling issues, they take care on hardware outages, stuff like that. And they take care on the egress and ingress, so on the external traffic and internal incoming traffic. And the developers are responsible for staging and deploying their applications, and even for running them in production. And there's just one thing where we still have an open discussion. It's regarding this enabling debug level on per container basis, for example. At the moment, we can only do that for a whole application. So when you have the same application run 10 times, then you can just activate the debug level on all of these containers, not on a per container level. And this is something where we now work together with the developers so that they say that development supports operating and getting the proper tooling for allowing them to run and manage an infrastructure. Did I miss something? All. Developers for applications and ops for infrastructure. It's the only way how things can work in that way. Because the ops people have they even don't like to know what's happening inside the container. The only thing they claim is we have 350 gigabytes of log streams in the past 8 hours. That might not be a good way. Please look at your container. It's throwing funny exceptions.
Some more questions? Still have plenty of time. All right.
Now it's coming Thomas who's asking questions. And Thomas is giving a talk about bringing Kubernetes into production. Okay, go ahead.
Thank you for pointing out the complexity. So you cannot underestimate the complexity of these solutions. So, and it's more a remark. In our experience, you mentioned Kubernetes security. You need 5 days to teach experienced security people what's going on with Kubernetes and container security. So it's not, it's like whatever we have to enable AppArmor or SE Linux and something like this. It's a more integrated view on that, and this is the complexity of the entire thing. A Kubernetes cluster has a complexity of an entire data center. And if you have a network, then you have border gateway protocol involved, probably not the simple Flannel network which comes out of the box. So thank you for pointing out it's complex, and it's even more complex than you can tell people in 1 hour.
Now you should know that Thomas teaches Kubernetes to other people, and when Thomas says he needs 5 days of explaining the stuff, be sure when you do it without Thomas, you need 5 weeks of understanding the stuff.
All right. Another question? Okay, so thank you, Martin.
10 minutes too early with a break?
Yeah.
I hope you don't mind.